Unit 1, I think this is lesson 12, right? I said 12 yesterday, but today is actually the 12th. Okay, so we're doing rational exponents part 1. So we're talking about how you view them, or what it actually means when you have an a to the 1 over n. Okay, so for example, we're just going to do a couple of warm-up here to kind of understand the relationship. So complete and evaluate the following. You have root 5 times root 5. We know that's what? Yeah, root 25. So we're all familiar with that, so that's good. And then the next piece we have is we have the 5 to the 1 half times 5 to the 1 half. So we're like looking at this kind of, I don't know, relationship between these two problems. So again, root 5 to root 5 is root 25, which we know is 5, right? Square root 25, cool. Okay, but now look. 5 to the 1 half times 5 to the 1 half, well, what do we do with the exponents? We add them. And what's a half plus a half? A whole, right? So you get 5. Yeah, not a quarter, that's multiplication. Okay? So you see we got the same spot. So let's just, that just means deduce a meaning for 5 to the 1 half. 5 to the 1 half is equivalent to what? So deduce means like, what's your conclusion based off what we just did? Your conclusion should be, excuse me, sorry. Your conclusion should be that these are the same thing. Root 5 is the same thing as 5 to the 1 half. Right? Root 5 times root 5, we get 5. 5 to the 1 half times 5 to the 1 half, we get 5. So that should be your reasoning. So deduce the meaning, 5 to the 1 half is equivalent to square root 5. So now we're going to take a step further, complete and evaluate the following. So root 2 times root 3 times cube root 2 times cube root 2 times cube root 2, we know is cube root 8, 2 times 2 times 2, which is equivalent to 2. Right? Cube root of 8 is 2. Okay, so, all right, we already knew that. Now let's do it with the fractions. 2 to the 1/3 times 2 to the 1/3 times 2 to the 1/3 equals 1/3 plus 1/3 plus 1/3. I have 3/3. I have a whole 2. Adding fractions. That's all we're doing there. They have common denominator already. So deduce the meaning for 2 to the 1/3. 2 to the 1/3 is equivalent to cube root of 2. So we're setting the stage right now for what fractional exponents are. Okay? So what I'm going to tell you is that the bottom, the n, is your index of your radical. What's the index of radical? That goes back to lesson 5 in the first section. The index is this number. Right? Okay, so this 1/2 meant square root. 1/3 meant cube root. Okay, we'll talk about the 1. We'll elaborate on the 1 later. I think for the beginning, we're just going to make that a 1 for now. But that can be a 2. We'll get to that in a second. Any questions on that? So the numerator of a fractional exponent is the index of the radical. So if I said this, let's just make one up here. If I said 4 through 125, that'd be 125 to the 1/4, because that's the 4th root. Questions? Okay, we'll keep going. It's early. I know this is really, really foreign. You probably haven't really seen before. So write the following radical form and evaluate manually. So with verify with the calculator. So 25 to the 1/2 is square root 25, which we know is 5. 64 to the 1/3 is to the 1/3, so that's cube root of 64, which we know from our note card, that's 4. 81 to the 1/4, 4th root of 81, which is 3. Okay, write the following in radical form. This is just with variables, so we're just going to say, okay, so that's square root of x. That's cube root of b. That's 10th root of p. That is n root of a. So we're just really hammering home the definition that the numerator of the fraction, denominator of the fraction is the index of the radical. This book likes to be repetitive. Okay, so now what they're going to do is they're going to put something on top now. We're talking about something not being a 1 and where that goes. Okay, so let's look. So the meaning of a to the m over n. So complete and evaluate the following. So if I did the square root of 5 cubed times the square root of 5 cubed, okay, what would that be? Anything radical times itself is just that thing. Okay, if you're not understanding my lingo there, what I'm saying is if you had root 6 squared times root 6 squared, you get just a 6 squared. Just like when we say, like we did at the top, root 5 times root 5 was just a 5. The radical times the exact same radical is just the radicand without a radical now. Okay, you're welcome to multiply that if you want, but you don't need to. Okay, so this is 5 cubed, this is 125. Okay, it's a good time for questions. This is probably going to be the hardest 2 lessons of the unit. It's the last ones. Okay, so don't just say, I'll just miss these on the test and see how I do. Okay. Okay, so then what they're going to do now is they're changing a fraction. 5 to the 3 halves times 5 to the 3 halves. So I'm going to go 3 halves plus 3 halves, which is 6 halves, which is 5 cubed. 6 over 2 is 3. So 3 plus 3 is 6, over 2 is 3 again, which equals 125. So again, you're seeing, so deduce the meaning of 5 to the 3 halves. It's the square root of 5 cubed. So what we're trying to get you to understand, the exponent of the radicand will be the top. The index will be the bottom. That's how it's going to go every time. So whatever exponent of your radicand is, with a 3, will be the numerator of your exponent. Whatever your index is will be the denominator of your exponent. Okay? So that's why at the beginning it was a 1, because why? We didn't have any exponents on the radicand. It was just numbers. So it was just 5 to the 1. They don't write a 1. Okay? Any questions so far? This is the meat of what we're talking about. This is the whole thing kind of at once, and then we're going to do some things with it. 90% of the things that you're going to miss in this section is if you can't add fractions. If you forgot common denominator, if you forgot your fraction rules, then you're going to be in trouble. Okay? All right. Okay, so let's just keep going here. Let's look at another one. So we have 2 squared, the cube root of 2 squared, cube root of 2 squared times cube root of 2 squared. So that's going to be the cube root of 2 to the 6th, okay, which is going to be just to, just be 2 squared, yeah, because there's 3 of them. So 2 squared, which is 4. So we come over here and we do the fraction model. I add them up now, 2/3 plus 2/3 plus 2/3. Okay, I get 6/3, which equals 2. 6 over 3 is 2. 4. The same exact spot again. Okay, so deduce the meaning for 2 and the 2/3. So 2 to the 2/3 is equivalent to the cube root of 2 squared. Yep. Okay. All right, got a couple of these examples here, and then we got couple more things we're going to lay out before we get to just a bunch of examples. So write the following in radical form. So again, this is the index. This is the power on the radicand. So it would be cube root x to the 5th. This is a 3 here. Okay, cube root x to the 5th. Next one, 5th root b to the 4th. Square root, don't have to put the 2 there, you can if you want, p to the 5th. And lastly, just the general term, nth root, a to the m. All right. All right, next page here. All right, warm-up number 3. Okay, so evaluate a to the 2/3 equals a to the 1/3 squared. So we're just kind of writing it a different way. So it says, because we know that when this is power to power, right? So 2 times 1/3 is 2/3. There's just another way of writing it. Okay, let me say that again. If I put this 2 out, write it like this, we know that 1/3 times 2 will be 2/3, because this is the multiplication of exponents rule. Why does writing it 8 to the 1/3 help me? Because we know what the cube root of 8 is. What is the cube root of 8? It's 2. So then now you can write it as 2 squared equals 4. It's another way of kind of breaking that down. Kind of looking for a cube root that can be helpful. So then with the fractional exponents, then doing it a different way. So we have 8 to 2/3. So instead this time we're pulling out a 1/3. So 8 squared, well 8 squared is 64. What's the cube root of 64? It's 4. So it's just kind of showing you that they both ways work. Now, do you have to do these? No. All we're doing right now is we're proving that the 2 is, we're proving that this goes on the inside right now. We're proving that that 2 goes there in the radicand. We're proving that this 3 is part of the index. And we're just kind of showing you relationships of that transpiring. So here we go and take the 2 out. We go, okay, what's 8 to the 1/3? It's 2. We square that, it's 4. We'll take the same thing, and we're just going to switch it. Pull the 1/3 out. Okay, 8 squared now is 64. Cube root of 64 is 4. We land in the same spot. It's the same problem. It's the same calculation. Okay, so which of the calculations above is easier method of evaluating? I'd probably say the first one for me, but this is preference, so you can't really be wrong, but I'd say I. So write the following in radical form and evaluate manually. Verify with the calculator. So like here, what I would do is I would write this as, I'd use it like this. I'd write it as 64 to the 1/2 cubed. So 64 to the 1/2 really means what? The square root of 64. 64 to the 1/2 means the square root of 64. What's the square root of 64? 8. So now we can write it as 8 cubed. And that would be 512, correct. Okay. So again, I'm going to take the numerator, I'm going to take it out. I'm going to write this as 4 to the 1/2 to the 5th. 4 to the 1/2 means the square root of 4, which is 2. Now it's 2 to the 5th, which is 32. Okay. 81 to the 1/4 cubed. So you may not know what the 4 through 81 off the top of your head is, but you can calculate that. Okay. You can still put this in your calculator, guys. If you put your calculator like this, if you go 81 up caret, okay, that's on the right side of those TI-83s and 84s, whatever you have, put a bracket, 1 divided by 4, it'll do it. Okay, if you put in your calculator like that, it'll do it. Okay, and it'll kick out a 3. So then we get 3 cubed, which is 27. So 27 will be your answer there for part 3. Okay, any questions or concerns? Okay. All right, use exponent laws to simplify. So here we have 2/3 plus a negative 2/3. What would that be? What's that? 8 to the what, though? 2/3 minus 2/3. It's nothing. It's 0. And so the only thing I was just telling Noah that because he's right. It's technically there's just an 8 there, but it's a 0, and that's important because anything in the 0 is what? 1, not 8. So that's the only reason I had to adjust what he said there. Okay, so we had a 2/3 plus a negative 2/3, which is 0. Anything in the 0 power is 1. Now, guys, let's think about this for a second. How does that make sense? Well, this makes sense because, let me take it a step further. If I have an 8 and a positive 2/3, right, and I'm timesing it by 8 and a negative 2/3, let's say it was right, those are positive exponents. Where would the negative 1 go? Huh? Below it. And now you have same over same. So it's 1. So I'm showing you that if we rewrote this with positive exponents, this would go underneath of this. Then they'd be the same thing. So it's 1. Okay? Use the resultant a to write a to the negative 2/3 in the form of positive. Oh, I didn't even know it was coming. So I just did that. Got ahead of myself. Should write a book sometime. All right. All right, so right below that, guys, is the kind of like the definition form. So this is what it tells you. It's just right here is the form. A to the m over n is the same thing as nth root of that whole thing to the m, or nth root of the m on the a, like inside the radicand. Okay, a to the negative m over n is the same exact thing, but just on the bottom of the fraction. Same exact thing, but on the bottom of the fraction, which we already knew that from yesterday from our integral ones. Okay, so that's all they're showing you there. And let's get some examples now. Write the following in radical form and evaluate without using a calculator. Verify with a calculator. Okay, so we're going to go ahead and write these. Again, there's a lot of different ways you can write them. Again, I just focus on what index do I have, and then I'm just going to go, okay, it's 25 cubed. To me, that's the way I like it, but the other way they showed up there, you can also write it square root of 25 cubed. Doesn't matter which one you do. Okay, I guess the bottom one might be a little easier because we know what the square root of 25 is. What's that? Don't say it all at once. It's 5. Okay, you guys are worrying me. 5 cubed is 125. So 125 would be that answer. Okay, I'm going to give you guys about 3 or 4 minutes to try these here. And then we'll start up there with Josie's side today. So, Josie, you have that one. Logan, you have that one. Maddie has that one. Lauren, Hannah, and Isla. Okay, so we'll see how you guys do on that, and I'll pause the video for a second. Jose, so just tell me how you wrote it, and then tell me what you got. Okay, did you have the 4 on the 1,000 or the whole thing? On the 1,000. Okay.
And then I got 10,000.
Okay, and then she got 10,000. Okay, so the only thing I would say is obviously 1,000 to the 4th is a really big number. So she's going to have to use a calculator for that part. Okay, maybe she doesn't. Maybe she's a whiz. That's fine. But if you take the 4 and you write it like this, we know what the cube root of 1,000 is. It's 10. And then you have 10 to the 4th, which is why she has the 4 zeros here. Okay? Just something to think about. Okay, Logan, how about C? So tell me how you wrote it first.
I wrote it 1 over 3
Cube root, yeah.
cube root of 27 and then 0.7.
Okay, so the important piece here that he did well is that it's a negative, so he just took the problem and he put it on the bottom. Now it's a positive and we're okay. So that negative is no longer an issue. Okay, and that's why I was saying I saw a couple of you guys that walked around and you guys put negative answers. This negative never affects the outcome in terms of your sign being positive or negative. Does that make sense? It affects top and bottom. Okay, Logan, then what is the cube root of 27 squared? So I'll do it here. All you got to do is what's the cube root of 27? So it's 3. Okay, and then what's 3 squared? 9. So it should just be 1 over 9 here. Okay? So remember, you can do these out of calculator. You can do these out of the calculator. All right, back to Maddie.
I did 16 divided by 4.
Okay. Oh, okay, so you wrote 16 to the 1/4. Okay.
Yeah, equals 2.
Okay. Can I do this real quick?
Yeah.
So she's going this method, which is totally fine. Because she just pulled the top number out. Okay, and she knows what the 4th root of 16 is. The 4th root of 16 is 2. Correct, Maddie? Okay, so now what's nice about Maddie is she has 2 to the negative 3. She can do what with that? Make it positive. She's put on the bottom. So she can just go, oh, cool, I got 1 over 2 cubed. And then what did you end up with, Maddie? 1 over 8. Okay? Don't be confused that there's multiple ways to do it, but find a way you like to view it and do it that way. Okay? Cool. Down here to Lauren. So now there is a negative in the problem, so this is something we have to think about. Okay, but go ahead. Okay, so you went negative 8 to the power of the 1/3. Awesome. Oh, and then you had the... Oh, okay. I got you. What kind of 2, though? Did you put positive? Okay, so a cube root of a negative is a negative because it's odd. So it's going to be a negative 2. Okay, so she's going to get... So I'm going to just kind of touch this up a bit. I'll just make sure you have this up here. Okay, and so she did the inside. She's going to get negative 2 is the only thing she messed up, and now she's going to square a negative 2. So your answer is going to be the same, actually. That became a little bit of luck, but it's okay. Okay, what's negative 2 squared? You should have got 4, right? Okay, is everybody good with that one? And then we're going to look at Hannah's, is similar. And we'll see if does she get a 4 or negative 4. Okay, so the difference is Lauren had negative in brackets. Hannah doesn't. So the negative is not going to be affected by the exponent at all, correct? That's the difference between the two. Okay, go ahead, Hannah. So how was yours written then? Negative. Okay. Gotcha. Okay. And that's 64. And then cube root of 64 is? Negative 4. Perfect. Good job. Negative 4. Any questions there? Nope. Perfect. Yes, Luke? No, because it'll work this time for you because this is squared, but you're not supposed to put on the inside, no. Because this right here, this exponent is only on the 8, not the negative. So the negative is outside this work. Okay, so that's a good question, but it's important to understand that if you did put in there, you probably still got the right answer, but that again was coincidence because the powers were even. It helped cancel them out. Okay, Isla? Okay, so she just, whatever's in here is to the 1/2, so whatever's in here is in the radical. Okay. Perfecto. 5. Okay. Questions? All right. Okay, so I will do the next 2, and then we'll go to the next section, and I'll get the rest of you involved here. So I'll do these 2 here. Write the following in radical form, evaluate without using calculator, verify with calculator. So these ones has fractions. Okay? So fractions shouldn't really mess us up too much because we're still going to do what we're comfortable with. So what I mean by that is this is still my index. So I'm going to go square root of 9/4, and then I'm going to cube it. The reason I like that is because the square root of 9/4, 9 and 4 are both what? 9 and 4 are both perfect squares. So this is an easy fraction for us to square root. It's just 3/2, right? Square root of 9 is 3, square root of 4 is 2. So I have 3/2 cubed. Whoops. And then when we cube, okay, where does it go on a fraction? Yeah, it's the top and the bottom. Goes to both, correct. So 3 cubed is 27, 2 cubed is 8. So 27/8 is our answer there. Okay, now we're looking at the exact same thing, but with a negative 3/2. So all that's going to happen here, if we have a negative, what do we do with the fraction in our warm-up? Flip it. So it's just going to be 4/9 to the 3/2. I'm going to do the same process. Square root of 4/9 cubed, 2/3 cubed, 8/27. So as you can see, it's just flipped. Because the negative exponent, the negative 3/2. Yeah. All right, so Denise, you have A here. Luke, you have B. Then we'll jump back to Aiden. Then we got Caleb. And then Noah. And then Raj. Andy. Spencer. Perfect. Okay, so give you guys a couple minutes to do those ones, and then we will talk about those. And then we have 2 more examples. All right, so Denise, how did you write yours? Okay, cube root r, that's all you need. Good. Luke, how did you write yours?
I got
Not cube root, right? Seventh root. 7 through S4, good. Okay, this one's a negative. So Aiden, how did you write yours? 6 root t. Okay, and then Caleb. 1/v cubed. Oh, it'd be v cubed square root. Yeah. Yeah. Okay. Okay. Good. All right. Noah, A. So what was that solution there?
I got 64 squared cube rooted.
Okay, 64 squared cube rooted. So you have 64 squared, and then you're cube rooting that, which would be, I think, ends up being 16. Okay, good. How about yours, Aiden? Or not, sorry.
64
Raj?
cube, or like 2 in the box thing.
Yeah, so negative 64. So then you have squared cube.
Yeah, and then that equals 4,096.
Okay.
And then that's 16.
Okay, good. Good. All right, and how about yours, Andy?
I got 64 cube and then square root of that. And then 8 cube equals 512.
Okay, good. And then, Spencer, why can't we do yours?
Because it's odd exponent with a negative number.
Close. You said it backwards. Odd exponent is good for negatives. Your problem is not the odd. Your problem is that 2 means you're square rooting a negative number, right? So, but if you're talking about this being odd, maybe that's what you meant. If that's okay, I see what you meant. So, yeah, you're square rooting. I see what you said. So he's square rooting a negative, and it stays negative because of the odd exponent. Okay, so that's what you meant. I understand now. You're good. But either way, the problem is we're having a negative in the radical of a square root. Okay, that's the problem. Okay, I'll finish these two off so we can be a little quicker and get you guys to your quiz, and then you guys have practice time. Okay, so a cube has a volume of 60 meters cubed. Okay, or sorry, 60 cube meters is how you're supposed to say those. Write a power which represents the edge length of the cube. So what would the edge length look like? Well, if you write with a power, it'd be 60 to the 1/3. If you want to cube root it, right? That's how you write with an exponent with a like in terms of cube rooting. So like when we want to find the area of a square and we have the area, excuse me, we want to find the side length of a square and we have the area, we square root it. When you want to find the side length of a cube and you have a volume, you cube root it. Okay? Writing cube root as a fraction is 1/3. Okay? So 60 to the 1/3. Write a power which represents the surface area of the cube. So how do you find the surface area of a cube, though? Well, surface area of a cube is how there's 6 faces on a cube. Think about a die, right? And then each one is length squared. Okay, the edge squared. Okay, so I'm just talking about like that's one face. That's L times L. There's 6 of those. Okay, well, we want to figure out what the length is, so we're going to write 6 times 60 to the 1/3 squared. Because 60 to the 1/3 is used, this is how we get the length. That's how we get L. Okay, and so then we can simplify this based on what we've done today. It'd be to the 2/3. 2 times 1/3 is 2/3. So that's the simplest you could write it there. That would turn out what the surface area is. Use calculator to calculate the edge and length of the surface area nearest tenth. So when you actually do that, the edge length is 3.9, and the surface area 92. Okay. Okay, write the number 10 in the following forms. So you write an answer of 10. So this is saying as a power of the exponent of 1/2. So what that's saying is, what square rooted is 10? 100, right? So it's 100 to the 1/2 equals 10. That's what it means. 100 to the 1/2 equals 10. As a power of the exponent of 1/3, so that would be 1,000, yeah. Okay. All right, and that's it for the notes.